In this video, we are going to talk about covalent bonding and covalent compounds. And so earlier this week, we talked about ionic bonding, which always occurs between a metal and a nonmetal via a transfer of electrons. We also talked about metallic bonding, which always occurs between metals, and now covalent bonding, which always occurs between two nonmetals. And so here in this little animation, you can see how a covalent bond occurs between two nonmetal atoms. These little atoms are just showing their valence electrons. We're going to pretend that this is a fluorine atom, for example, with 7 valence electrons. And so I told you earlier this week that single electrons are the electrons that can mingle. And so the single electron on each fluorine atom is able to get together, okay, with the other electron on the other fluorine atom so that they can be shared. And that sharing of valence electrons is what creates a covalent bond. And this only occurs between non-metal atoms. And so that word covalent literally means to share valence electrons. The prefix co means to share. Valent refers to valence electrons. And so in a covalent bond, valence electrons are always shared between two atoms. And so the goal of covalent bonding is so that each atom in that bond can end up with an octet or get 8 valence electrons or a full outermost principal energy level, right? And we can see how that happened with these two fluorine atoms here, right? They each started off with 7 valence electrons, but by sharing their single valence electron, now they both have 8 valence electrons, or a full second principal energy level. All right, we can see this again with some dot diagrams. So for example, a water molecule is formed by covalent bonding between 2 hydrogen atoms and an oxygen atom. Each hydrogen has 1 valence electron, right? Those are single electrons, so they can mingle and be shared. And then oxygen has 6 valence electrons, where 2 of the valence electrons, this one here and this one here, are single so that they can be shared with other atoms. And so this hydrogen and its 1 valence electron is going to get shared with this single valence electron on oxygen, forming a single covalent bond right there between the hydrogen and the oxygen. And then the same thing is going to happen with this hydrogen and its 1 valence electron and this single valence electron on oxygen. And so those 2 valence electrons will end up being shared and form a second covalent bond between oxygen and another hydrogen, which creates the water molecule H2O. This also happens with chlorine. Chlorine has 7 valence electrons. And so the paired electrons on chlorine's dot diagram are not able to form covalent bonds. But the single electrons, they can mingle and they can form covalent bonds. And so this single valence electron on chlorine here and this single valence electron on this chlorine are going to get together and allow themselves to be shared between the 2 chlorine atoms, which creates a single covalent bond between chlorine and produces what's called a diatomic molecule. A diatomic molecule is a molecule made up of 2 atoms of the same element, right? Di means 2, atomic refers to atoms, so diatomic means 2 atoms of the same element coming together and forming a molecule. Okay, a molecule is somewhat like a compound. However, in a compound, you typically have to have 2 different elements, or at least 2 different elements making up that compound, right? Compound is like you're combining 2 different elements, whereas a molecule can be 2 different elements, or it can also be 2 atoms of the same element sharing a covalent bond, or sharing electrons via a covalent bond. And so several elements exist in nature as diatomic molecules. We'll talk about these more when we come back to class on Monday. But the 7 diatomic molecules are your 4 nonmetal halogens, so fluorine, chlorine, bromine, and iodine, as well as oxygen, nitrogen, and hydrogen. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine always exist in nature as diatomic molecules. That means you'll never find a single chlorine atom floating around by itself. Okay, when we talk about chlorine, it's existing as a diatomic molecule. The oxygen you breathe is not singular oxygen atoms. They're oxygen diatomic molecules, right? So two oxygens sharing, in that case, two pairs of electrons. And so once again, a covalent compound is made up of two or more nonmetal atoms, and that compound is formed by the sharing of electrons. And another word for covalent compounds is molecules. So I like to think of a covalent compound as being a nonmetal plus another nonmetal. Some properties of covalent compounds include low melting points, right? Covalent compounds are only made up of nonmetals. Nonmetals have low melting points. Hence, covalent compounds are going to melt at low temperatures as well. Many covalent compounds do dissolve in water, but many do not dissolve in water. We'll talk about the solubility of compounds a little bit later in the course, but one property to understand and one property that we're going to see in lab next week is that some covalent compounds do not dissolve in water. And finally, covalent compounds do not conduct electricity when dissolved in solutions like ionic compounds do. That's because covalent compounds are not made up of ions, okay, held together by their opposite charges as ionic compounds are. So they are not going to dissociate into ions when placed in solution. Additionally, covalent compounds are only made up of nonmetals, and nonmetals do not conduct electricity. And so compounds made up of nonmetals like covalent compounds will not conduct electricity either. And so the last thing we're going to talk about is how we name and write formulas for covalent compounds. So the general rules are that we name the element that's furthest to the left on the periodic table first, then write the name of the element that is farthest to the right. We always change the ending of the second element's name to read IDE, just like we did when naming ionic compounds. And finally, we have to use prefixes, okay, to indicate how many atoms of each element in that compound are present. And so let's look at some examples of this. So our first compound we want to name is H2O. The regular everyday name for H2O, of course, is water. But the scientific name, or the IUPAC name, International Union of Pure and Applied Chemistry name for water, follows those rules we just discussed. And so we have two hydrogens. Our prefix for two is di, so we would say that we would write dihydrogen, and then we have one oxygen. Well, we give the IDE suffix to oxygen's name, so it's going to become oxide, but we also have to have a prefix to indicate that we just have one oxygen atom here, and that prefix is mono. So what we're going to end up with when naming this compound is that it's called dihydrogen monoxide, right? Two hydrogens, one oxygen, and oxygen's name gets an IDE ending. So dihydrogen monoxide. Next is N3S6. Well, N is nitrogen. We have three of them, so we're going to add the prefix tri to nitrogen's name. And then S is sulfur. It's our second element, so we give it an IDE ending, so that's going to become sulfide, and there's 6 sulfurs, and so our prefix for 6 is hexa, so we'll end up with hexasulfide. So when we write all this out, we're going to get trinitrogen hexasulfide. And then lastly, CO2. Okay, we just have one carbon here, so you would think that we would just have to add the prefix mono to carbon, but there's actually one exception to the rule for naming covalent compounds, and that is that we never ever put the mono prefix on the first element in that compound, right? And you'll see why that is here in just a moment. But we have two oxygens. Oxygen is our second element, so it gets an IDE ending and becomes oxide, and we have two of those, so it will be dioxide. So this compound, as you've probably already guessed, is carbon dioxide. Now, I mentioned that we never put the mono prefix on the first element in the compound, right? And that's something that you probably realize when looking at this compound, because we don't say monocarbon dioxide, we just say carbon dioxide. So that's one rule that you do need to remember for naming covalent compounds, is that the mono prefix never goes on the name of the first element in that compound. It can go on the second element, okay, so we could have carbon monoxide, but we could never have monocarbon dioxide. Next, okay, we're going to do the opposite, where we talk about how to take a name and write a formula. So first we write the chemical symbols for both of the elements in that compound, right? In the name we'll have prefixes. We just match the prefixes with the number of atoms that prefix represents. And then we write those number of atoms as a subscript beside the chemical symbol for that element. So if we have carbon tetrachloride, right, remember we never put the mono prefix on the first element, so if you just see that element's name, that means you only have one atom. So carbon would just be C when we write its symbol, and then tetrachloride, chloride is chlorine, so Cl is its symbol, and tetra is our prefix for 4. And so we would name this molecule CCl4. Since we have one carbon, you could also write C1Cl4. That would also be acceptable here. Then trinitrogen hexaoxide. Nitrogen is N. Tri means 3, so we have 3 nitrogen atoms. Oxide is oxygen, so O, and hexa, so 6 oxygens. So this will be N3O6. And lastly, carbon monoxide, right? There's no mono prefix on the first element, so just seeing the name carbon tells us we have one carbon atom. Oxide is oxygen, so O is its symbol, and we have one oxygen because of that prefix mono. So this formula would just be CO, which you could also write as C1O1. All right, and so that is how you name and write formulas for covalent compounds. You're going to do some practice with this for homework, which we do on Monday.